Works a lot with Postgres. He works at Heroku. Heroku recently launched or released 9.4 support, Postgres 9.4 support in January with JSONB, and I'm using it for one of my projects, and it is fantastic. So thank you, Will.
Yes.
If you guys have ever used the watch command in Postgres, have you ever done that? You can watch a query. So you can be like, select star from users, and watch that like you would a Linux command, and it will just continue running the query and show you things that pop up in the users table as you monkey about in your UI. And he did that. That's Will's patch.
That part's true.
This is a fact. That's pretty much the only fact I've stated so far. His name really is Will, though.
Yeah.
Welcome to Will.
All right. Thank you. So I want to talk a little bit today about building APIs and some considerations with that, and then introduce at the end a tool called Pliny. And it's a appropriate tool for this conference because it's a beer-themed Ruby library at a beer-themed Ruby conference. So I think it'll fit right in. And it's actually super easy to use. The first step is you open a bottle of Pliny. The second step is you write your API, and then it's better. Thank you. I wanted to bring a couple cases of Pliny to share it with you because I'm sure not everyone has had it. I don't think it's probably not the best beer, but I think it's definitely one of my favorite beers. And so it's brewed by Russian River Brewing in California, and I looked to see where they distribute it. And there's a couple places in Portland, and I was flying in through Portland, so I drove to the first one, I think it was Belmont Station, and I went in there and I was looking around the bottles, didn't see it, so I asked the guy, hey, do you have this? And he said, unfortunately, Russian River stopped shipping bottles to Oregon, and that I could try going to Washington. And I was like, nah, that's okay. So unfortunately, I don't have any Pliny to share with you all. But if you're in San Francisco, it's on tap at a bar called Tornado at all times. I'd be willing to go with any of you. So just a brief overview of what this talk is going to have. The first part is going to be a little bit on services, why sometimes you want to split your app into multiple services, and then also why maybe you shouldn't. And then the next part is going to be sort of needs that API-centered apps have, and finally it'll be on the tool Pliny itself. So first off, why services? So there was the good talk yesterday about how sometimes you can avoid having services and still have a productive monolithic app, and that's great. But sometimes you might want to split some things out into services. As the code becomes more and more complex, having very harsh separations between the things can have more discipline. And often I've working on a large code base. You want to go and add something to it, and you get unexpected breaks and unexpected failures, and it can sometimes be a little like this. Let's watch that one more time. Oh. Yeah, that's sad. No, I'm gonna block it out. It's a little distracting. And so, so one of the nice things about having a service, separate service API, is that it can be more single purpose, and that does make things. It tends to make things easier to understand because you're only looking at that one part. Easier to maintain for sure, and some of the other benefits is that you can scale these different parts independently of the other parts. And if it is a different type of thing that could benefit well from a different language or different set of tools, you can then make those sort of choices. But I think the real reason that I've seen services be important is that as teams grow, that's more so than the technical challenges. Larger teams starts to sort of push this need for services. I remember the first time that I heard that, I think Conways Law, where it says that systems tend to reflect the social structure of the people who built them. When I first heard that, I sort of took that as a challenge because I was like, oh, there's no way there's no technical reason for that. So let's try and fight that and make the systems as they quote unquote should be, regardless of the social teams and such. But lately, thinking about that, I think it's sort of inevitable. And rather than spend time trying to fight that, if you sort of like embrace that and know that it's going to happen, instead spend your energy and time on thinking about how the team should be structured, because the software is going to end up like that anyway. And so spending more time thinking about the teams is valuable. One of the things is it's much easier to coordinate inside a team than across teams. And when you have things in their own code bases, you can iterate on them independently. That said, there's a lot of reasons to sort of beware services and not do them. Over the last year or so, there's definitely been a lot of people talking and a lot of articles and so on about microservices, and it's always kind of rubbed me the wrong way because a lot of these articles and stuff only talk about the upsides and all the great things and don't mention that services they're extraordinarily expensive. It takes a lot of energy and a lot of time to do them, and I see these things sort of glossed over, and it kind of makes me uncomfortable. And I suppose really that though is just all these sort of things go through the same sort of hype cycle, and we're just have to ride that out. But I did want to spend some time in talking about some of the reasons why maybe sticking to the monolith a little while longer might not be so bad. As mentioned in the intro, I am somewhat database focused, and when I do see when you split a service into separate apps, you give up on having everything in one database, and there's a lot of advantages that you're throwing away there. Transactions, being able to update several records at once and make sure they all commit or all roll back is great. Joins are phenomenal. Rather than pulling megabytes and megabytes and megabytes of data into the application just to do the join there, doing that all where the data lives and then only giving the result back is much, much, much more efficient. And reporting is a lot harder when you no longer can just mash out a SQL query. You have to you write a script and do API calls all over the place. Just to put that into, that's sort of abstract. To put that into more of a concrete example, one of the tools I've worked on a lot is the tool that handles all the provisioning, monitoring, and so on for the production databases at Heroku. And so when you add a new one, the call eventually makes it to this thing, and it spins up some EC2 instances and installs it on there. If one of them goes down, it handles the failover situations. It makes sure that all the continuous backups are all where they should be, and so on. So it does a lot of things. It's actually has a ton of responsibilities, and one of the problems that we've ran into, it's not a huge problem, but this is just one problem, and a lot of them stack up, is that the interface that we have with the main part of Heroku is the same interface that any add-on provider has. There's a couple little things that we have, but largely that's the case. And there's another Heroku feature where you can put apps into organizations, and so they can all be everyone on the org can have access to all the apps. Now, the way that works for whatever reason is it changes the owner to be organization name at herokumanager.com, and internal teams have their own organizations for all this, and the customers, their apps are in the same thing. It's all at herokumanager.com. And a lot of the internal people, they want to be treated a little bit more special than the customers. They're not. And they want, like when we're going to do a maintenance or something, they want a little bit more hand-holding. And it's hard to tell which ones are customer apps and which ones are internal apps because it's all at herokumanager.com. Is that the end of the world? No. But it is one of these small prices that you pay that you don't necessarily think about up front when you're doing these services. The other real problem, though, is that each one of these things needs to have its own deployment story. It needs to have its own versioning story. It needs to have its own monitoring set up, its own pagers hooked up. All the dashboards need to be put up. And depending on how, it's a nice way to put this, mature your organization is, there might be just like paperwork, like doing all these checklists on security checklists on productionization checklists, making sure it's categorized and inventoried correctly. And all that can really add up. So I guess all that is to say is like, sometimes it is the right thing to do to split out something into a service, but please, please, please consider it fully. You're all very smart and talented, so I'm sure you've thought of this, but it's something to think about. So next part, let's look at some of the things that when you're building an API, some of the considerations that you might have. There's this guide that the API team put up called HTTP API Design Guide. It's really originally named, and it's a log markdown file of a lot of things that you can consider when you're making an API. Some of the things are very straightforward and sort of basic, but they're in there to cover the bases, and that's like using e-tags to help with caching, making sure you look at the accept header so you're sending back the right data that the client wants, making sure you use the appropriate status codes on all the answers. Some other things that are very good is making sure all the dates are formatted the same way, so ISO 8601, and then it goes on to some more things that I thought were pretty novel and interesting, one of them being request IDs. So if you specify a request ID when you make a request, any requests that system sends out to other systems will include that request ID and append new ones on. And when you get the request back, you'll see your request ID again. And that way you can trace sort of, in a sort of distributed system like this, that these services are just going to be one part of. If all your logs are in one spot, you can sort of trace, what went wrong, what's going on, and that's really helpful. Another thing, it touches in things more like how to design your URLs and such, and they advise to minimize path nesting, so you can have a little bit of paths. Excuse me, like apps/app ID/releases/release ID, but don't go crazy having like really deep ones. Like when you can, try and fold them in to be more shallow. And the final one that I want to talk about a little bit is, because I thought it was super interesting, is range headers. You've probably used range headers unknowingly when you're downloading a big file and then it has to resume. That's how the servers handle that, is with a range header. They suggest using this for API pagination. So if you're only going to return like 100 things, you can have your clients send range headers to get the next ranges, and that's a nice thing to fit in. There's the URL one more time. There's a bunch more that I haven't gone into, and if you have any questions on any of the things or you think something's wrong, feel free to open up an issue on that GitHub repo, and the people who maintain it would be more than happy to discuss some of these issues with you. Finally, on to the main part of the show, Pliny. So Pliny is a Sinatra-based tool that was extracted over the course of a long period of time from the main Heroku API. And so the story there goes that Heroku started out chiefly as one giant Rails application, and over the course of time, they've migrated away from that somewhat. And I remember I was working on some patch, and I had to modify some stuff in there, and I discovered that there was a file called app.rb, which handled apps. As you can imagine, that as you might fear, that was a very large, huge God class of terribleness. What was worse was the upgrade bang method, which, if you remember your old Rails, that's how you handled state transitions from one state to another state. And so anytime like anything changed, it would go through this one gnarly method. Fortunately, it's not like that anymore. What they did was they took all of the Rails code and put it into a vendor directory on a new framework, and wired that all up so it was all that. And then slowly over the course of I don't know how, like quite a while, they refactored it out into new patterns and new ways of doing this, and learned a lot as they were going on with that. It's still using Active Record, but now chiefly Sinatra. And they took all the things that they learned from that and put it into Pliny. And one of the things I really like about Pliny is that the same way that Rails removed all the little small decisions like how to lay out your file structures, how to name your tables, how to name columns, all those sort of like little small decisions, which each one of them, is very small and like doesn't really matter, but they all add up to be, quite a burden if you've taken them all at once. And what's even worse is when you go from project to project and all those conventions are different. And so that was, I think the best thing that Rails did for the community was that sort of thing. And Pliny does a lot of those same things, but for API decisions. And so some of these decisions include things like versioning your API from version to version and supporting multiple versions at once, doing standard logging and getting enough information in the log line so you can debug things later. Configuration support, so when you're running the thing in a staging environment versus the production environment versus your local environment, that the configuration changes are all in one spot and minimal. And also, when you're serializing JSON data to go out, having all the serialization stuff be contained in sensical. So there's 3 parts of Pliny that I want to talk about, or 3 categories, let's say. The first is things that help you with management and ops of your application. The second is interactions between this service and other services. And finally, the things that they have in place to help you as the application grows. Most of the examples that I'm going to show are from an application that I wrote called Telex. It's open source, although I don't think that anyone else is really going to be interested in running it. What it does is, when any other systems in Heroku need to notify a customer, I noticed that they were all doing it in different ways, and some of them would notify just the owner, and some would notify the owner and the collaborators. The templates were all different. Like, it's a very hodgepodge situation because everyone was reinventing this themselves as it goes. And so I wrote this to be a centralized thing to do these sorts of transactional notifications, and it handles all the work of plexing that out into all the collaborators and so on. And so I made it open source because I had the advantage when I was writing it when I was using Pliny to look at the API source code, but most people don't have that advantage. So open sourcing this as an example, so when people are looking into using Pliny, they have an example to work for them. There's one other open source example that I know of. My colleague wrote Transferatu, which is a PG backups restoration and backup service. It's replacing the PG backups add-on soon, but this is also open source, and it has a cool logo. So actually the main thing that I really like about Pliny is that it's in Ruby, and I don't have to sell Ruby that much to this audience, but there is one thing I think that is really cool that isn't that thought about or talked about that much, and that is being able to open up a production console in a production environment. And this one feature, like these sort of APIs that Pliny tools are written in, it really could be any language. I mean, it's mostly just taking in a request, making a couple of queries, making some API calls, or somewhere else on the other end. Like, it doesn't really matter the language because it's all IO bound anyway. It could be Python just fine. But after spending a couple years working on this control plane software, not having IRB as a main interface would have been really painful. I remember during some of the really bad Amazon outages, being able to fire this up and write some small programs to manage a bunch of servers, fail them over or something, being able to, under duress, being able to not have to worry about white space sensitivity or limitations in the REPL was really a lifesaver. And some people have argued with me that, oh, your service should have all the possible APIs to do everything, but that's not really feasible or thrifty. I mean, sure, you could do it, but there's so many other things that you could be working on. Having the entirety of your application as an API as a last resort inside IRB has been just a lifesaver. It uses Postgres, which I'm a huge fan of. And the other thing that it uses, to use Postgres is SQL. Has anyone here used the SQL library from Jeremy Evans? That's a good number, but not nearly enough. This is a fantastic project. I don't know if there's a project maintained better than this one. I mean, not to say anything to other project maintainers, but if you go to SQL and look on GitHub, there are no open issues. There might be one. And that's not because no one opens issues. That's because Jeremy Evans like closes them and solves them like all like just I can't imagine. But this is one of the reasons I also really like SQL is that it lets me write the Ruby version of my queries the same way that I would have written a query anyway. So this is taking when a user wants to see their notifications, I want to pull in their notifications. Notifications can have follow-ups, so like notifications, hey, your database down, and follow-ups, okay, it's back now. And I want them to be ordered sort of like Gmail, with the most recent notifications at the top, but the follow-ups are going down chronologically. And I also want to do it in just one query. The type of queries that a lot of ORMs, not just Rails, but all the ORMs I've seen, they usually generate the first query to get the IDs of the things it wants to join, and then does this huge where in, and then the list. And like that's not terrible, but it's a little gross. And this way, with this eager graph, it does both joins as necessary. I can have some where filters, and then Postgres' date time math is phenomenal. So I can just say where it's less than a month ago there, and then do the sorting. And the SQL that it generates is really similar in structure. I mean, this is the select, the joins, and the where clauses in the order. So being able to have that be as close to one-on-one as possible is really nice. One of the things that the API design guide talks about is JSON schema. And Pliny makes it really easy to actually use JSON schema. And what's nice about this, if you hit api.heroku.com/schema, you can get the entire machine-readable things you can do with the Heroku API. So this example here, it has this is a description of an app, and then the properties, so there's a name and it has to be unique, and here's the regular expression that we validate on. And then it has links of things that you can do to it, and this is truncated, but that's sort of nice. It's not so so one of the nice things that it lets you do when you have this sort of thing is you can generate clients. So an example of this is there's an experimental Go written replacement for the CLI called HK. And sort of the boring, repetitive things of talking to the API, all that code is just generated from JSON schema. So whenever new things are added or things are taken away or they're changed slightly, all that stuff can just be generated. And it's also good for when another service is talking to your thing, you can make sure that everything is all wired up correctly. The other really nice thing for your application if you're using JSON schema is you can have tests to make sure that you're not regressing any of the things you promise your API does. And then also when requests are coming in, you can match it against the schema and sort of get automatic error messages for, oh, this doesn't validate this, you're missing this field or this isn't formatted right. So those sort of basic validations can just sort of be done for you. That said, I still have not done a JSON schema for Telex. I personally view it as something you do more when the project is pretty stable and you're like not iterating on as much. And one of the last, not the last thing, but one of the last things that Pliny does really well is serializers and versioning. And what it lets you do is it has a first-class place of describing all of your serialized responses. And there's nothing magic here. It's just building the hash. But having it treated as a first-class thing with a little bit of wiring around it makes it nice because you can, when you're doing different versions of your API, each one of them can be named appropriately to the version, and that way there's like a place to look for that. And you're probably going to be supporting at least 2 versions of your API at any given time, like one that's deprecated on the way out, but you still have to support for a little while, and then your current one. And then as soon as you end up deprecating that, you're probably going to make yet another version and sort of keep that cycle going. So having these sort of things be a first-class thing is really handy. And finally, the last thing that Pliny does really well is it has first-class support for mediator objects. Now, over the last couple of years in the Ruby community, there's definitely been a lot of talk of things around this concept. I've seen the same idea or similar ideas go by many different names: interactors, managers, just plain Ruby objects, and so on. This is the sort of take on it that Pliny went. And the idea here, for those of you not familiar with it, is that it's a set of objects that sort of encapsulate the interaction. And that lets your models be chiefly just validation and persistence. It lets your controllers or endpoints be just doing authentication, authorization, and pulling the right objects out and responding. And it really makes testing easier to do because you can just test one little part of the thing as you go. And it also really helps you understand the system because rather than having a class with a bunch of methods that are only tangentially related, but still deal with that class, you can look at sort of the things that your application does in a piece-by-piece basis and only have to consider one part or another part at a time. An example of Mediators from Telex, this is the thing that actually does the plexing of a message comes in from someone who wants to send a notification, and then it looks up who that's supposed to go to and creates notifications for each one of those people. And this is nothing fancy. We store the message, we get a user finder, and that'll behave differently depending on if it's a message intended for one person, such like a billing event, or if it's something that's targeted to an application like the database went down. And then we get the users, we create the notifications, and this is the whole thing. It's small. It calls out one of the things that's a nice pattern is calling another mediator, and so we can describe each one of these different things that the application does as different parts. And to be honest, some of these things, as I was trying to follow the patterns that Pliny says you should do, a couple of those mediators really did feel a bit like overkill because I was like, hey, I'm doing something pretty simple. This is kind of overkill. But seeing the end game, seeing the API the Heroku API source code of how this plays out years from now, having a good skeleton in place, I think it pays off huge dividends in the long run. Pliny also has a number of other things. I'm not going to go into detail. It has CORS headers, so your JavaScript applications can talk straight to the service. It has a request store, which does a thread local variable to store some information about the request that you want to sort of pass around, and it takes care of cleaning that up properly at the end of each request. It has a really nice configuration management thing where you can say these environment variables are required, and if they're missing, the app won't boot. These other ones are optional, and it sets a default, and then these other ones it doesn't matter. It has Puma out of the box configured, and it uses a roll bar for error reporting. And there's a bunch of other things. I recommend that anyone who wants to give this a shot, if you have any questions, please reach out to me or open an issue on the project. I think it's really great having a common set of tooling for when you start having several different APIs. Having them all on the same base makes it easier for your team to go around and look at all these different parts. And it's really been quite enjoyable to write a thing with this. So I recommend that everyone tries it. Thank you.